All right, hey there. We're gonna get going doing some more of this conf-go stuff. I have been out using my paper and pencil coding. Sometimes when I need to like crack a tough design, I'll do it on paper and I'll get away from the computer. That's what I've been doing this morning. And it turns out the solution to what I want to do is actually a lot. It's of course it's all about simplifying it. And what I have is it's probably too convoluted, the stuff I've had so far. So I'm going to simplify that. I'm going to do some things that are pretty radical um, in terms of ripping out what I already had, even though it was like a limited 1.0 release. So that's fine. I don't think anybody's going to die. There's no dependencies listed in the Go site on it yet. There's nobody using it, including me. So I was actually going about the process of using as a consumer when I realized I wasn't going to be uh, I wasn't going to be satisfied with what we have right now. So I still want to leave everything we have. Part of the problem I have right now is that um, the changes are going to make it so that the package as it is right now, this whole entire interface and all the tests are probably almost all going to have to go away and be redone. So that's fine. That's fine. We'll do like an iterative process here, and uh, and basically chuck this one, store it aside, and then bring it back in and say, hey, this is what we're going to change here. But I'm going to go ahead and tag this one. I've already ripped it up pretty bad. So actually, I'm going to revert this one to the last changes, and we'll go forward from that point. So, um, people might think I'm being a little bit, pedantic or anal on this. The fact of the matter is that this is going to be a configuration library that so a lot of things are going to use of mine, and I don't ever want to have to revisit this again. I'm kind of tired of revisiting it. The most recent revisit came from I forget who it was, but somebody in the Twitch chat informed me of the cost of interfaces, and I took him to task. I was like, no, I don't believe you. And I've since read this article and followed up. I haven't done any public lab analysis of it. I really feel like I need to do that to be able to truly acknowledge that this is a problem. But let me just read this. This is a very short overview of the article. Let me read you what's wrong with interface. It's 2009, so I'm guessing this is 1.16, maybe 1.17, and I'm just going to read it really quickly with you. It's a pretty short article, but before we get into this latest refactor, uh, so having this been brought to my attention, and then having somebody who obviously does a lot of high performance Go development bring it to my attention. I know that because I forget the name of the person who did it, but I know that they were doing high performance because they actually use SyncMap. That's where the conversation started, and they use sync.map, which I made a video about. That says never use SyncMap, and they said, well, actually, it's really good if you're just doing it on the right. Let's go. I'm back on track. I mean, I'm on track. It's everything's still fine, um, but the 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 use of interfaces as I was doing it. So I want to revert the thing, and I'll show you, was definitely incurring a pretty heavy cost. But I'm going to talk about why I'm still okay with interfaces in our case because of the use case, and I'll get to that. And I'm gonna make some conclusions up front in this video, so you can decide whether you want to watch the rest of it or not, and we'll talk about Go. But this is the article that triggered the conversation, and so let's just read really fast. So Go interfaces, but at what cost? So if you don't even know what a Go interface is, this is going to be very foreign to you. I'll give you a brief description of what an interface is. An interface is a way of adding a method to a struct specifically, right? And if you want to call it object, fine, but it's not. That is consistently the same. So I'll give you an example of an interface. So let's see here. We go doc FMT. So in the FMT library, Yeah, we're going to talk about what an interface is right now. Okay, so somebody's asking this, so I'm going to talk about what an interface is. So if we'll talk about what an interface in general is, and then what an interface in Go is. And I'm only going to spend about 5 minutes on this. So if you're bored with this, you can go to something else. So as you can see, you have this type here in the FMT. This is so what an interface does, whether it's Java or Go, is it says this thing, we'll call it a thing because I don't want to call it an object or an instantiation of a class or any of these other complicated things. This thing has an operation, and that's the true name. It's not a method. A method is the implementation of an operation. So walk would be the operation, and the steps for move your left leg forward, move your right leg forward, move your left leg forward, that kind of thing. The algorithm to do it is the method. Even though people use the term method all the time and incorrectly, that's common in interface. Usually when somebody says method, they mean operation. So strictly speaking, an interface says this thing can do this operation. And it defines that by saying, here is the name of the operation, here's what arguments the operation will take, and here's what it will return. And in addition, an interface usually includes documentation above it that describes to everybody else who's going to implement that operation with a method, everybody who's going to implement it is going to agree this is what we require. All right. So this is called coding by contract. It says here is, if you implement this operation, if you create a method that implements this operation, thou shalt do the following things. Make sure that the changes are safe for concurrency. You're going to go out and do this thing. So you have a very general description of the expectation for anything that implements a method that fulfills the interface's operation. So unpack that last sentence is really important. So when you declare that something, when you declare an interface, when you say, okay, here is an interface, you say, this is what, let me give you an example. So the very specific, very common example is what's called the stringer. So you got type stringer here, right? So let's do, is it all? I can never remember. Go FMT stringer. All right, so this is the stringer interface. This says that if you implement the stringer interface, you will add to your thing, struct, but you will add to your thing an operation called string that returns a string. And if you have that, you fulfill the interface. Now, why do you give a shit? Why do you care about doing that? Because if you create anything, you can have, in terms of Java, you can have any class, you can have any structure in Go, you can have anything possible. We don't care about all of the other things that it can do. We don't care. When we want to say, I might want to make a function, okay? I might want to make another function that takes, it doesn't care about what's being passed into the function, except for one thing. Does it fulfill the stringer interface? Does it have a string operation? And so when you, in a strict type language, whether it's OOP or not, you can say, okay, I'm going to make a function and I don't care about the thing coming into this function, the argument, except for I need to be sure that it has a string method. It has and that means that it has an actual step-by-step algorithm code written to fulfill the string interface called a method. So then you would say, so if you want to say that, you might say foo takes, temp foo.go. You might say that func foo takes a stringer, right? So it takes an FMT stringer as a type, right? No return value. And then we could say s.string, right? So So this is why interfaces are valuable, because interfaces allow, it's not really polymorphism, but what interfaces allow you to pass a thing, anything, and to strictly define it in your arguments as saying, I can pass anything whatsoever as long as it fulfills the stringer interface. And because of this, it's actually kind of, it's not really, I don't know if policy is the word, but because of this, it's usually standard practice to make very tiny interfaces, to make one or two, operation interfaces. Why? Because the same thing might be able to implement, like the one I'm thinking of doing is like getter and a setter, right? So conf.getter, conf.setter. I now have an interface. I've declared that this, and I might make a struct, that fulfills both of those interfaces by adding the set method and a get method and defining it and, doing it right, making sure it's concurrent and ACID compliant and all this stuff to make sure it's good. And so you're setting up the rules for engagement, and then other people or other things can use your type. So an interface, that's why an interface is a type. It's a type. It's a type just like an integer is a type. So I am going to pass a stringer as a type, and the type literally is anything that implements the string method. The end. And so that's what an interface is. And using interfaces really frees up. Let's see. It obligates to give behavior. Can you make a collection of the same types that implement the same interface? Absolutely. Yes, you can. And people do all the time. And it's actually, it doesn't even matter. You can declare an interface. I can declare an FMT stringer interface that says thou shalt have a string method, right? And I can also have a conf.stringer interface type that is exactly the same. And anything that has a string method fulfills both requirements for those interface types. You see what I'm saying here? So if I wanted to do this, I could even say this. I could say, I want to make my own, right? So I want to make my own stringer interface because, maybe I want to have different rules for my stringer interface. The rules, by the way, are where? They're documented right here. A stringer implements this and has concurrency safety and blah, 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 blah. Right? And there's no way for you to force people to implement your interface that way. You've just well documented, hey, if you're going to fulfill this interface, these are the rules, right? And I might have slightly different rules for fulfilling my interface from the FMT one. And so I could say, you have to have a string method and it must return a string. That's it. And so now I could change foo. I could say foo has to have either an FMT or it could just be a stringer. This is just local, right? Or it could just be a stringer. And it removes you from the problem of, whether you're passing by reference or you're passing, it doesn't matter, right? So if you pass, by the way, if you pass by type, by interface like this, I don't think it's as required for you to define whether you want a pointer to that or something. We won't get into that. That's going to get confusing. So that's what an interface is. And interfaces are the way to save you from a lot of bad things. In fact, people have suggested that, interfaces are the way to save you from Java coding. So if you're coding in Java and you're coding with single inheritance, you're doing it wrong, even though Java forces you to use single inheritance. You should never use it. You should almost never use single inheritance in Java. The creators of Java were asked in a meeting, in a conference, the three amigos, one of the three amigos, I can't remember which one, the people who invented, class-based OOP and Java and everything. Crazy popular during the 90s. There was a great thread about OOP I saw earlier in the day on the chat. Thank you for sharing all that. And that's, you got to go watch Jim Coplein's video on that if you want to get started and read about what's wrong with OOP. And somebody asked him, if there's one thing you could change about Java and OOP, what would it be? And he said, inheritance. And everybody laughed. They thought he was making a joke. And he was dead serious. He would have taken out single inheritance is the way it's been implemented in Java, because multiple inheritance gives you the diamond problem, and C++ is plagued by that all the time. But so it's just really interesting. It's just really interesting. So interfaces save you from that, right? So instead of saying this is a thing, you say this has a thing, right? So interfaces are more. So like if you think this, I didn't mean to do this on this video, but I'll go ahead and say it. So if you really think about it, interfaces are how our world works. So if you look inside of an automobile, you look inside of an electronics product, you look inside of anything, it all comes down to its interface. What are its inputs and outputs? And that is it. Or this knows how to do a thing. Yeah, that's a good one too. It has this capability, right? So you don't care when you add an alternator back to a car. Nobody does this anymore, but let's say you had to add an alternator to a car. You don't give a shit how it's implemented. That's encapsulation, a different concept. But you don't care shit about how it's implemented. You just need to know they're going to be able to communicate with the thing, and it can that it'll plug in. And that's what the word interface means. You have plug interfaces that work in Europe. You have ones that work other places. You have some, crazy adapters that allow you to use multiple interfaces and stuff like that. But it's all about plugging things in and focusing on the connections. It's not focusing on, okay, I have a vehicle, and this vehicle is a bicycle, and this vehicle is a car, and this, and they all will move me around and stuff. Inheritance and object-oriented stuff, single inheritance is really bad. It's because you just wanted a banana, and now you have the whole fucking jungle. That's why. And if you don't understand why single inheritance is bad, you probably should spend an hour or two and do your own research on that. Single inheritance is really fucking bad. You should generally not use that much inheritance at all, and you should define all. This is a solid principle. Go look at it. Go read about solid and all of that stuff. All the things that have come out since the decline and downfall, if you ask me, of OOP, to try to make existing OOP usable again, because now it's been a move. It's been a move entirely away from inheritance and a move towards interfaces, and that goes for Java, and that goes for C#, that goes for C++, it goes for Go, everything. The world has pretty much concluded that class-based object-oriented programming with strict single inheritance is a fucking fail, and you really want to catch up if you haven't figured that out yet, because they still teach that way in school. You can't pass the AP Science test without declaring in blood that is the way, even though that way has been completely and roundly debunked by computer scientists for the last decade. So everyone asks you for the OOP concepts because they don't have a fucking clue. Dude, most employers have never heard who Jim Coplane is. They don't know what class-based OOP is. They can't tell you. I couldn't tell you the difference between them 3 years ago. But I've done a lot of research on it since I started hearing about people really bagging on OOP. Brian Cantrell has the most entertaining video on this I have ever watched. He talks about, is it time for Rust as an operating system? He concludes, no, C still has shared memory, which is fastest interprocess communication, et cetera, even though he formed Oxide Computing with tons of Rust in it. Watch his video. Is it time to rewrite the operating system in Rust? There's a segment in there where he talks about the dark times when OOP ruled the land, and it's just fucking hilarious. It's like the best possible IT stand-up or coder stand-up you could ever hear. That and Jim Coplane's video, which is referred earlier. These are not commonly known things, except for the people who've had to write code a lot. And those people have been burned by this stuff, including me. We've all been burned by inheritance in some way or another. It used to be that inheritance propagated the entire tree to even be called. It was so slow, it was insane. And now they have, tree shaking, all kinds of other ways to get rid of that level of indirection. But still, the point is, you want to just use interfaces, because then you don't care. You can actually have a leaf, sort of thing that implements a ton of other interfaces, and it does it by how? It might be it's importing things, right? So bottom line, use composition over inheritance. All right. If you're not using composition and aggregation are way, way better than inheritance. because you're combining pieces together that have common interfaces, and you're embedding them and building bigger things, and then you're building bigger things out of those things. There's no inheritance going on. You're doing what you would do in the physical world. You're combining things together through composition, and composition requires the use of interfaces. All right, so that's probably enough for me on that. You can read a lot of stuff about this. About learning Rust or Go. You can learn Rust or Go. It's up to you. Go will get you a job. Rust won't. Rust is ugly as sin, but people seem to like it. That's all I'm going to say about Rust and Go today. Every major application in the cloud native space has been written in Go, including Docker, Kubernetes, K3OS, CoreOS, etcd. I mean, I could go on and on. So, somebody asked about Rust and Go, and I think you should learn Go if you want to make money. If you just want to dick around, or maybe get a job at Amazon someday, or Oxide Computing, one of the 2 or 3 major computer companies, they might play around with Rust. Just don't buy into this shit. Go watch Rust Reality. I have a playlist called Rust Reality. Make sure you watch that first. And if you watch it and you still want to learn Rust, fine, go for it. I don't care. I didn't find it, but there's an article from 2003 talking about inheritance in a conference interview with James Copeland, Java inventor. What would you change? I'd leave out classes. Right. Yeah, that's when you found it. Did you find it? Yeah. Yeah, that's exactly the one. I said it wrong. I'd leave out classes, and classes are inheritance. I think that was it. That was definitely it. Thank you for finding that. So let me copy that link address and put that in the YouTube chat as well. So that the post is, looks like somebody found the actual article. God, I haven't looked up this article in 10 years. I can't believe you found it. It's 2003. Yeah. Yeah. Thank you so much for finding that. I've been looking for this forever. I want to put this in my, yeah. Yeah, I'm going to put this in my set really quick. Great. What is it called? Is it Gosling who said it? Yeah. Java inventor. James Gosling would leave out classes. All right. So I need to probably do a video on this. I'm so happy you found that link. Thank you so much. I can't overstate my joy that you actually found that link. It's really great. James, yeah. Just don't get me started. You gotta be, to be fair, I coded a lot of Java. I bought really solidly into the Java ecosystem. I gave presentations on it. I got headhunted out of Nike, where I did their shopping cart in Java, and then I got headhunted into IBM to code Java, where I never coded a line of Java, even though I was hired to code it, because it was the .com bubble burst while I was in training, and I had to shift real fast over to sysadmin. And I did. I worked in sysadmin and, wrote out the .com bust, and then I got, jobs back in coding as well later. So, yeah, thank you very, very much for finding that. So yeah, JavaScript, you want to change platform? Well, you can't go wrong with Go right now. I am not an evangelist for Go. I have found Go very useful. I'm about to bag on it for the next hour because of interfaces. So look, I call it like I see it as best I can, and sometimes I call it wrong, and I'm about to tell you a time how I called it wrong. So don't people might come down on me as being pedantic or opinionated or overly opinionated and everything, but I'm going to give you a solid example right now of me calling myself out for being wrong, for not having all the information. And being wrong because you don't have all the information doesn't make you a bad person, by the way. It doesn't mean you have to double down on and like defend your language or your position. It's not about your ego. It's about getting to the truth. What's the most efficient thing. And I think honestly, I think I and others, we get mischaracterized as being so opinionated that we're unable to change. And I'm about to show you how I'm willing to change when given new information. So let's go find it. Maybe did I already kill it? Damn it! I hope it's still here. Where did it go? I hope I didn't close it. I hope I didn't close it. I think I do have it's in my history, so I can go find it if I need to. Go interfaces. Okay, so back to Go interfaces. so so that's what an interface is. An interface. Now, what is the practice and Go for interfaces? This is not talked about very much, although there are a few books recently that get into it. Interfaces, as we said, are a way to make your code very flexible, even though it's very strictly typed. I don't care about anything else of my type other than it implements this interface. Okay, so interfaces, and I mean, there's other methods to make strict type languages more flexible. You know, generics is coming in 1.18. And then Go has an additional unique thing called the untyped interface, which I won't talk about today, which is not this. Don't confuse the untyped interface with this. The untyped interface is when you pass in a thing and you say it takes this. An untyped interface is it's a thing that has no type that you care about. And this is something that was added by Go. It's not the same as this. This is a true interface. You know, they're just really picky about compilation speed, so they reuse the name interface. So that's what's up. So we're going to go back to here, and we're going to talk about this. So we'll go back to the actual interface. You know, FMT stringer, we'll say. FMT dot stringer. So the stringer interface in the FMT library says, if you implement a string method, anytime your thing is used in a print context, that will be called. And it's a method. This is an interface that is built into Go. So this is a good solid example. So Go doc FMT stringer. So right here, if stringer by any value, anything that implements a string method, it doesn't have to be a struct, by the way. You can associate methods with integers in Go. Yeah, because it's not class based. It's not. It's one of the coolest things about it. And I don't want to get into it, but you can take any type and give that type a method. Any type. You could make a Boolean and give it a method. It doesn't have to be a class. This is why it's so important that you don't use the word class anywhere when talking about Go, because there's no classes. There are things, there's structs, and then there's methods that take a receiver, which are, it's kind of like, you can kind of imagine it as creating a struct and then hanging off of that struct methods that effectively take as their first argument the receiver, you know, the thing. And so you could have, what I'm trying to say is you could define a type bool, and then you could have whatever, you know, the receiver is, and then give it a string, and you could actually use this to make a true false, print the word true or false. Yeah, if it uses that particular type. Yeah, Rust is horrible. I don't recommend Rust in my, if you can't tell us why Rust is good, please don't recommend it to beginners, particularly to beginners. If you don't know, if you haven't been coding for a while, I'm gonna tell you, don't jump into Rust as your first language. Learn C first. Learn a little bit of C, and then learn Go or Python or JavaScript, and then wait for Rust till later when it actually matters. So many beginners get into Rust and they just get in trouble. That's all I'm going to say about that. And pause for beer, but it's knocked me out. Yeah. So here we go. So the stringer interface, if anybody has it, it'll print it out. Do you know why there is a stringer instead of type string interface? Because of the name conflicts, usually, denial of service. Type error interface, error string. Are you telling me what's up with that? Why there is a stringer instead of type string interface? I'm not following. Example, type error interface, error string. Oh, I don't know. No, I don't. I see what you're saying. No, but that's been away for a long time. But yeah, for what is, you can build real quick. That's the reason. All right, so this is what the interface is. So let's get back to my problem, because I really want to deal with that. my problem is, and I see we've got our friend back on Twitch who who sent me this article, and we're about to talk about it. I was like, no, I don't believe you. And the reason I didn't believe him or them was because I thought that it was abstracted away by the compiler. And this is the reality check that says, nope, that's not true. So I want to go through this. It's a very short article, and I'm just going to read it. There's a cost associated with using interfaces. What is the cost? Let's try to work it out. So I told you about all the positive benefits of using interfaces, right? It allows you flexibility in your signatures and all of this stuff. But that flexibility comes at a cost. And how big is that cost? And that's what I want to determine. And this article is the beginning of talking about how big that cost is, so that when you make the decision to use an interface, you don't want to just consider how is this going to make my code easier and more, I don't know, polymorphic and easier to, use. How is this going to affect everything after that? And I don't want anybody to freak out about this. I mean, IO Reader, for example, and Stringer, there are interfaces used at the core of the standard library that are constantly used, and they're always used, and they are not a problem, and they're not going to change anytime soon. I mean, using interfaces in Go or any language, modern language, is a pretty standard thing. The thing that's a little bit disconcerting here is that when you use an interface, you may be like me, and you don't realize how big the cost is of using an interface, or abusing the use of interfaces when you don't know. So, and I'll show you how I did that, how I used interfaces and incurred costs that I definitely don't need, just for the sake of code organization, as opposed to, code composition, composing my code with another person. I did it primarily for the ability to document each individual interface, which is probably not worth the performance cost. So this is stuff that you might not be thinking about at all. And I want to bring it up because I missed this particular thing completely. So let's start with the basic overhead of calling a method via an interface. We'll define a very simple interface with a single method and a very simple implementation. We'll also mark the method as inlined by the compiler when we do this, so that the call to get isn't completely removed from direct case. This is super important. When I read this, so the reason that, first of all, I didn't know until today that you could mark a method with a compiler directive. Compiler directives begin with the comment and then go semicolon. These, and I know I've used these for generators and all kinds of stuff, and which OS to compile for, blah, blah, blah. You'll learn about them. But I didn't know that there was specifically a way to sort of annotate a function and say, I don't want you to inline this thing. And I have a feeling this is why I missed this, because I've done benchmarking in general of my applications before, and I haven't directly compared the interfaces versus non-interfaces, but my performance stuff has been relatively good. I haven't ever gotten, first of all, I haven't been writing super high performance code that might have to do, millions of hits a second or some shit, which is the reason you might use sync map and context and all these other things that you normally would not use. You shouldn't use sync map. I made a whole video on it. 90% of the people should never use sync map. But this, like that, that 10% of people that are doing really high performance computing and Go, where they're handling lots and lots of requests and stuff, they need to think about these optimizations. And so this is one way to test that. Inlining, by the way, inlining means that if your compiler, the more intelligent your compiler is, the more it can change a function and then replace a call to that function anywhere in the code with the exact code. So you can think of it as if your compiler is going through all of your code from top to bottom, all of it. I mean, every file and everything. It says, okay, I've got this function here. It's pretty simple. So it's just returning an integer. It's kind of a waste for me to go call that function every time. You know what I'm going to do? Since I'm a smart compiler, anytime somebody calls this thing, I'm just going to pretend like they just wanted to cut and paste this line right here. Okay. They just wanted to cut and paste this line right here as if it were right there. So anytime there's a function call to get, in this case, a zero would be put there. The return value would be put there as is. If you did a mathematical function, I mean, and this is where it gets tricky, because if you try to start guessing what the compiler is going to inline and what it's not, then you're kind of in premature optimization space, right? And that's a bad place to be, because you don't want to. People will do crazy shit in C all the time, with different operators that make no sense when you look at them as a user or as a developer, but that hyper optimize the underlying code that gets generated. Dude, it's just super bad practice to do that, because later on they might change the optimization of that code and they might blow up your whole thing. So don't do it. Don't do premature optimization. But in this particular case, I mean, people would say deciding not to use an interface is premature optimization, and you should be thinking about writing clean code that others can understand and that can be integrated much faster, because that's what's going to take you the most time in the end run. And any of these performance hits that we're taking in Go, by the way, would only show up as negative in a comparison against code written in C, or maybe in some cases Rust, but because of the garbage collection, which we're going to read about. Otherwise, you don't care. I mean, you're talking about comparing speeds to Python or Ruby or JavaScript, even Node. No. So these these performance hits we're going to be reading about are absolutely negligible compared to any of the other scripting languages out there, or even some of the strict type languages. But this inlining thing was a discovery for me. This was like, so you can actually put a no inline if you want to actually do a proper test. So they do a simple benchmark. Benchmarking is built into Go. It's test framework, so you can write this. And it says benchmark interface call simple. So testing.b, this is how you write a benchmark if you want to read about it. I'm not going to get into how to write those. I don't write them very often, but it is kind of nice to write them. You can also cause benchmarks to not necessarily run every time. In fact, I think you have to indicate you want them to run when you run test cases. But so this compares the call to get with this call to get, and it shows you that one of them implements the interface and the other one doesn't. So here we have type 0 as a struct. We have a getter, which implements the get interface. And then we have get int down here. So this is the implementation. So here's the struct, right? So that's the type. This is the receiver. It says if I have a 0, I want to interface. This is my method. They didn't use a pointer or anything because they're not going to operate on the thing at all on the receivers. They're just going to return 0. So this, you can either go directly to the value inside of the struct, or you could use the getter to get it. And then they try it. So they compare the tests. One of them's calling was z.get, which is going to give you a 0. And then, so there's no data lookup. There's actually no memory lookup at all. They just prevent it from being inline. And then where's the other one? Did they do another one? What is G? Functional B. I'm just checking this. G equals Z. Okay. I see. So they just made a pointer to the other one. So one of them is gonna, well, that might not be fair. Actually, I just realized that might not be fair, because there's no 0 there. G.get is calling the getter. And I don't know about these others. Yeah, G.get is, no, this is a problem. I actually just noticed this, because there's no value here in this struct. Oh, var equals 0. This doesn't make any sense. So one of them is calling it with the interface. Let's see. Oh, okay, never mind. There it is. All right, I got it. So yeah, G is the interface. Yeah. So this one declares itself as being something that implements the getter interface, and this is declaring itself as just being a plain old struct. So this is an interface, and this is a struct. So G equals Z. This is the part I don't understand. I don't understand why they're doing that, because it should be making a pointer copy. It's not making a duplicate. Is it making a duplicate because it's a primitive? I think it might be. I don't know. So I'm trying to decide why that's to expose it to an interface. Which equals the, so we have the zero, and then we have the getter, and then the g equals z. So g.get, that one I understand. This is, I think this is kind of a cheap, it's kind of a cheap creation content. It's cheap. I see. Yeah, I see. Okay. So this is saying G is a Z and implements the getter, but it, because of this is what tells it to use the interface. And this one, but just using Z by itself doesn't care, it doesn't know that it has the interface. But you have to do this to do the instantiation. That, because you have to put some value in it. And the zero value is going to already have the zero value of the struct in it, which is just 0 period. So is it going to do z.get? Yeah. So when it does z.get down here, it just calls the get method, and this get method is getting called via the interface. It's being telling it this. Okay, I got it. I had to just track it down. It's not how it is defined in memory, but how it is used. One is direct structure and the other is interface. Yeah, I know. But this the thing that threw me is that this assignment would have to happen at all. And I realize now why that is. This has to happen because it's this has got a zero value and this doesn't. So the getter doesn't. I mean, I'm assuming that a getter doesn't get a zero value. I think that's what's happening, because that's how you create one of the things. You see what I'm saying? So this is all. That's what threw me. This is saying I have a Z. And it initializes it so you can use it down below. It doesn't have to do any assignment at all. And this one says I have my G is a Z, and that has to happen in order to because the zero value thing would, okay, that's interesting. That this should be, somebody should put that on a coding interview question. That's a cool thing. That's a cool thing right there, because there's a lot going on. If you can get your head around what's happening there, I think, and I probably need to look at it like 10 more times. You can have a nil pointer receiver. I know that's what throws me off. We were just talking about. I was just saying that people, they think of class-based library programming and Go you can have anything. You could have a true false. I talked about having a true false receiver, and type for with a receiver. Z is a static struct, so G will point to it, right? So G is pointing to that because it's a prime. But the whole point of this is to give G an actual reference value that says, hey, I am a getter. I mean, coming into this, I'm like, why doesn't Z need an assignment? And I keep forgetting Go for stuff like this. It's using Z as it doesn't need to do any further assignment at all, because it says I have one of a struct, and it's Z is defined as the empty. It's using the empty the empty struct. Yeah. So that's why G has to equal Z to say this equaling this. Yeah. Z is a struct defined somewhere, probably the heap in this case. Yeah, but okay. I mean, beginners are going to get really confused about this. I didn't make the Slack channel yet. No, Carlos, I'm not going to. It costs money. We'll talk about that another day. I'm gonna just do matrix only, but it's gonna take a long time. So I don't know how long Discord will be up before that, but I don't want to cut everybody off until I have it. I was also in perfect change if it's on the stack. So that's you're kind of spoiling this conclusion here. But when I saw that, I immediately understood the performance thing, and it's okay. So yeah, Z equals 0 and var G equals nil. So G needs to get, yeah. That's what's going on. So this performance hit for anybody this is not too big of a hit, right? This is completely negligible. And again, this is like nanoseconds, which is like crazy. But this is where stuff gets kind of annoying. And when I saw this, I was like, fuck, I got to reproduce this. It's so many things use IO Reader. And let's try this one actually is really this one kind of annoys me. And see what it does. Yeah, probably should do that. Would be fun actually. This conclusion is the one that really made me sad. Let's try something a little different. We'll create, it's funny because they actually bag on something that is one of my biggest complaints about Go. So not only do they share my opinion about that thing, they showed me how that same problem applies to any interface. And I was like, oh my God. Go compile-s. So let's try something different. Let's try an implementation of IO Reader that fulfills buffer with zeros. So IO Reader is a standard interface that all it has to do is return a byte array, a byte slice, just a bunch of data as bytes. That's it. And so they fulfill the interface for Reader by doing that, right? I'm not going to get into how or why that works, but that's the thing. And then they benchmark it. So our benchmark will follow very similar to the previous one. We're calling our implementation via IO Reader interface and directly. So they do exactly the same thing, but the difference with this one is that there's memory related. All right, so there's memory associated with the interface's implementation of read, or the method. The zero reader. It's got memory to deal with, and this is where things get ugly. So, everything else is the same. It's making, it's reading the buffer. This says to read the whole buffer, by the way. And this indicates that it's a 7-byte buffer. These are not normally seen in a lot of Go. This is an actual array that says it has exactly 7 bytes in it. You normally wouldn't use that. You'd use just a regular slice without defining how exactly this byte size and everything. But just suffice it to say, the output of this test is that it is like crazy hit performance relatively. It's still, in user time, it's not that fast, not that long at all, and be completely undetectable to the human. But to, a benchmark test on a non-noisy computer, which is another reason I haven't done my own lab, because my computer is way too noisy to do a solid, good benchmark. I actually kind of want to bring up a server in the cloud just for benchmarking, because I could make a container in the cloud or something, and I could make it absolutely bare bones and not have any noise. When you're doing benchmarking, you got to make sure your system's not doing anything else. Like all it's doing is a benchmark, because if it's doing anything else, it'll affect the performance tests. So, and that's really hard to get, even if you do lots and lots of iterations. So if you want to get into benchmarking, which is actually kind of fun, I should probably do that. I should probably start up a machine just for benchmarking. It's, $5 a month just for benchmarking. I don't know. Anyway. So you see that there's this huge hit, and the first thing I'm like is like, what the fuck? Why is it so much extra time? And then they go and they explain, in both cases, we allow 7-byte buffer before the read call. In the direct call case, the compiler knows what the implementation of the read call is, so it can apply escape analysis. And I don't fully understand escape analysis other than to say that it lets it make decisions at compile time. If I got that right, if I got it wrong, let me know. But the lay person's explanation of this, as far as I can gather, is that by having memory involved with the interface, it can do things at compile time that as opposed to runtime. And here's where it gets ugly. So, and can tell the buffer does not escape the stack and therefore can be allocated on the stack. And I'm not going to try to explain the difference between the stack or the heap right now. You have to get into computer science to understand that. I fully don't understand it myself. I just know that the stack is more efficient than the heap. The heap is where, runtime memory is managed during the computer, the program's execution. So, memory, if you're going to use a variable or something like that, space on the heap is allocated, and then it's popped off and it's just cleaned and freed and all that stuff, depending on what and that's where garbage collection comes in, and people slam on Go all the time for garbage collection, but it makes the language much more approachable and palatable. Python, JavaScript, most languages have garbage collection. It's not a bad thing. It's a more effective way of coding. It allows simpler code and stuff like that. But the rest of people would tell you that garbage collection is the devil. You should never use it, and you should write an extra 50 lines anytime you want to do anything related to it, because it'll help you write safer code that has no garbage collection. So whether you buy into that or not, that's fine. I still think it makes it unworthy of most rapid applications development, because the performance costs like this are totally negligible. But if you're talking about things where they aren't negligible, then yeah, you need to know about it. So the long story short here, I find it quite disappointing that any memory passed. This is the part that really makes me sad. Okay. And it's perfectly summarized in this paragraph. I find it quite disappointing that any memory passed via any interface will always escape and always require heap memory. Now, I don't know why they didn't, they could have gotten around this. They could have decided to make the syntax of interfaces more complicated, and provide ways for them to use, stack memory instead of heap memory, but they didn't. And whether or not they're ever going to do it is a different question. I doubt it, because that's not a priority. Let's see. Somebody suggests you should always slice your max. Oh, you should always set your slice max length if you know it. Of course. Yeah. But if you don't know your max length, then you can't. It's always way better than add. Yeah, I do that with maps too. If you know the size of a thing, then when you declare it, you should say, this is how big it is, so it doesn't have to allocate the memory every time it appends or changes the thing. The slice never contain more than 10 strings, yeah. I have a feeling that doing that probably puts it on the stack instead of the heap, right? It probably does. I don't know the underlying thing there. That would be a deep dive for me to go figure that out. Made it even less important to optimize code. Yeah, things like Kubernetes made optimizing the code less important. Shift complexity from performance tuning to horizontal scaling, which is hard, but it's a different thing. So the use of interfaces, this performance cost might be an issue if you're making a utility or some sort of high performance tool or service that was going to run on a computer all the time and is going to be in a situation where it's going to be destroying other things on the system because there's no separation and no boundaries. And I love Taniwa's point that this focus on performance and memory management and stuff, although important, God knows I'm that guy, is less important today than it's ever been before because of Kubernetes. Because you can slice everything up, or cloud native, you can slice everything up and say, you get this much memory, you get this much CPU, you can do whatever you want with it, but you're not going to affect anybody else. In the old days, coding like something like this and putting it on a central server with 1,000 other things that all have to run on that server would be a big deal, because it would be taking away resources from the other things. So the very fact that orchestration even exists makes a language that has GC that provides a simpler syntax that can be generated and written more quickly much more palatable, for the same reasons that Python and Perl were so palatable during the early 2000s and late 1990s, because they could deliver faster. And still, though, if you're going to pick an interface, func 10 string, if you can still use. Oh, right. Yeah, talking about assignment. So it's quite disappointing that the memory passed via any interface will also escape. In the case of IO Reader, the English definition of the interface strongly hints that the buffer should not escape. And this is what I find interesting, is that remember we talked about interfaces and setting up the rules, right? So here is the reader interface, and it says here, hey, if you implement this, you should really do this, right? Implementations must not retain P. So this is what I'm talking about, the contract. This is why you would do it. Go performance is just prep for the next generation of programmers. These days, nobody needs to care about it because Go is a billion times faster with misuse of interfaces than any other language. So even if you fail to do interfaces properly, and I would argue that I was overly zealous in having an interface full of, embedded interfaces, which I like because it makes it nice and clear for me to read. But that's probably an unnecessary overhead. And this is all leading up to why I'm going to change conf-go. So, so in the case of IO Reader, the English definition strongly hints that a buffer should not escape. Implementations must not retain P. Similarly, this is the one I have a gripe with. The JSON and Marshall are really bad. I don't like them at all, and it implies that the buffer should not actually escape also. That line on retaining P could be for correctness rather than performance. It might be. Yeah, I don't know. A Marshall JSON must copy the JSON data if it wishes to retain the data after returning. And then I'm not going to get into it. The JSON and Marshall use reflection and stuff, and they overly zealously HTML escape things that they shouldn't, such as every freaking Unicode character, which is a totally acceptable value within a JSON value, and they still insist on escaping them all for security reasons, which they don't need to. It's a different gripe altogether, which I'll talk about some other day. But I implemented my own JSON parser because I don't like what they do. Not parser, renderer. So anyway, would it be nice if we could express this on the interface definition in a way the compiler can understand? The reason that probably will never happen is because the priority in Go is keeping code simple and fast to write. He said, right before generics come out. But that's supposed to be the priority of Go. Unsexy, simple code that's fast to write, easy to understand, strictly typed, and cross-platform compilable. That is the mission of Go, and that has really, really high concurrency, and all of that. So that that's the end of that one. I did get some claps and stuff, but so what does that mean for me? So what that means for me in my little thing here. And I'm actually going to revert this branch probably. I was writing some notes, but I'm probably just going to chuck them. Yeah, I'm going to chuck these. I guess I'll just stash them. Yeah, so status. Bork is out of here. I can move my notes as temp for now. Test data got modified, so check out test data. What? Then I never added test data? Let me check. Sorry. Oh, that's it. All right, so Bork is a directory. All right, so this is what I had, and we're gonna go change this. You use JSON iterator-go instead of the JSON package. I didn't know there was another one. Let me go open this. Thank you for the reference. Thank you. I really appreciate you being here. The benchmarks for JSON, yeah. This is super cool. Oh my God, this is so cool. Yeah, I'm going to put this in my notes so I don't forget it. Yep. JSON package is very inefficient. Yeah. That create, consider not using, standard, what is it? Encoding JSON. So I'm gonna flesh this out with a bunch of alternatives eventually. I'm not using, what do we call it? Encoding. The built-in JSON library including the tagging of structs that forces the use of reflection is really quite bad. My biggest gripe is how it forces all Unicode character or code points to be escaped, even though they are completely valid JSON values. Here's a list of some alternatives. So I'm just going to keep a list of the alternatives here. JSON iterator. Yep. And I guess we'll do the tags. JSON. Okay, Golang. JSON. Anyway. Yep. I wonder if you can replace encoding JSON using GoToMod. You can't use the replace directive. We just found out that replace causes it to not compile, even if you use it for a method like that. That was really disheartening. Somebody's got to explain what the hell is going on over there, because they just yesterday, I was like starting to find some really legitimate uses to use to replace in a go.mod file and leave it there, including domain name changes and shit. In fact, there was a big time GitHub person who's I can't remember, is it Philippe, I want to say, but they were talking about using replace to change your domain name, so that if you wanted to use a shorter domain name but you wanted it to resolve to github.com, you could leave the GitHub stuff in there, and you could write the replace directive and leave it in your go.mod. But as of the other day, I found out you can't compile code, period, with a replace directive in your go.mod file. So somebody added a block along the way that stopped it from being used, because they were interpreting the problem, which is very real, of having people use replace to pull in localized things. So unless I'm missing something, unless that replace block, which we should probably check, is conditional upon looking for a localized thing, we need to look at it. But the whole entire point of replace is that the target for the replace has to be a local file. So, I mean, I don't know. Maybe I got that wrong. I got to look into the replace directive more, because go build Jags. I leave it for users to decide either way they want to build, standard JSON or JSON inter. Oh, that's super cool. That is really cool. That is really cool. There's somebody who does Go programming every day. I don't. I wish I could. So yeah, that is a really great idea. Okay, so let's do this. So here's a way to give people the option of using the built-in versus the faster one. So if they don't want any external dependency, which is another, anti-pattern, too many dependencies. I mean, all right. So that is not anything. I don't know why it's doing that. I almost understood something about Go interfaces, but interested in learning Go now. Yeah, they're a thing, right? The thing about interfaces, okay, so let me just net the interface thing out. Number one, interfaces are hard for beginners to understand. They're like, the first question they ask is why, particularly if they just came from C. And this is why I'm having a moment here, because I do like to help beginners learn stuff. And I've toyed with the idea of having Go as a first language, and I've completely dismissed that. I did a little bit of sampling on that with some students that I taught like several years ago that I helped to learn. And they were really, outliers. They were homeschooled. They were, and they figured stuff out, but they still expressed a certain amount of pain in the way that we went about it with the book we used and everything. So you learned the build tag trick from Jin. Yeah, look, I'm not saying Jin doesn't have great code in it. But I don't know if it's necessary for everybody to use it. So the other piece of this, so interfaces are already hard for beginners. The first question they ask is, why do I care? by the way, JSON devs included, which are bought and well known for their devs for their developments at Google. Oh, Matten. I thought Matten was at HashiCorp now. JSON, yeah, internal developers include T Hawken and Matten, which are Go devs, the main people behind Kubernetes. Is he? I didn't realize. T Hawken. I didn't realize. Uh, kind of up with where I think Matten's over at HashiCorp. I think I saw some of his stuff get ported over. I saw some of his work on the HCL stuff, the HashiCorp configuration language stuff. I don't know. But yeah, so okay, let me just recap the thing with interfaces. Number one, they're hard for beginners to learn because they don't know why they need to use them. And you can't get a beginner to understand why they want to use an interface. And so they're talking about, a lot of code. You got to start to understand how to make your code polymorphic and composable and all that shit. You have to care, and you don't care until you have lots of code. So I haven't even taught the higher level, development practices of, breaking stuff out even into multiple files and things like that. That's like something that comes far later in the beginner learning process. I mean, you got to learn the syntax and learn, what messaging are and stuff like that. There's a lot of things to learn before you start, going out, and even how to make a module, for God's sake. And then you start thinking, well, how am I going to have all this code share? And then finally you're like, oh, okay. So if I make an interface, that means any one of my things can implement it, and I can just, so all the value that comes from interface, you can't just say because interfaces are good, when you first start. And so it's tough as so much helping people learn to get them to kind of run into the wall where they realize, oh, hey, I need to use this thing. And frankly, I haven't run into the wall enough because my code bases are relatively small. Even my pagan, functional based parser for that meta language that I wrote is not complex enough to reach the level of like a Kubernetes or something. So for beginners like that, and frankly, because I am in the infrastructure operations engineering space, most of my code will remain relatively small scale. It's not going to be a part of a much larger thing. And even when I was doing, I was paid to be a software developer, software engineer at IBM those latter years before I left, I was doing mostly like C code cleanup and stuff, and I wasn't composing large code bases. When I was coding at all, a lot of times it was just writing K-shell code, K-shell or POSIX shell code that would run as points of audit points and stuff, running with big fix across multiple systems, blah blah blah. And my point is that you don't really understand things like encapsulation and polymorphism and all these big words from computer science or software development until you start working on large applications with lots and lots of code and having somebody else have to write code that you have to use. And then you have to start thinking about, okay, we have to have a pretty solid agreement here about how you're going to use my code forever and how, blah, blah, blah. That back and forth and that kind of situation is not something a beginner thinks about. They don't think about it, and they really shouldn't think about that. They got other stuff to focus on. So if you hit them with this stuff early, you should always pass interfaces, always return structs. Then you might end up doing something like I did, right? It's responsible for the Kubernetes logo, T Hawken. That's cool. I didn't know that. So I don't know. I feel like, I feel. So for this is, I've been coding Go since 2014 but smaller projects, right? But I still, until I read Learning Go, was the Riley book that just came out like 4 months ago, that had dared to actually have some opinions and idioms in it. There are two cases in which I consider for interfaces valid. One, if your package has multiple structs, and interface helps to make common slice of these types, or user can write their own implementations of your package. Default implementations, so that your package could accept these implementations as input at some type of function in your package. Right. And that's exactly how I'm using them. I'm using it because I want, and I'm going to define my interface here. I think I finally got it down to the minimum that I need. And I'm going to go ahead and implement a basic interface for this. And then I'm going to allow myself to implement any number of structs that implement this very minimal interface. And that's really what you want. You want that flexibility to be able to use, to take whatever it is that somebody might have a struct, and you might say, hey, I want to be able to plug my source of data into some other thing, and then have a single interface for the whole thing. So, and it really makes me want to like get back into the C coding, because in C coding you don't have the option. In C coding, I mean, how do they address this in C? I don't even know. I've never coded C at that level. I imagine they would probably use macros or some shit, but I mean, you don't have this, right? You have the one struct, like inode table, the file inode table entry, the struct comes to mind, and you never leave it. You never change it. You never change it. You better hope you got it right, because you can't add another one. It has to be that type of struct. If you change that struct at all, it will no longer work in any of your compiled code. It's pretty final. I mean, C is pretty damn final with its structs, and I feel like that makes C a lot more rigid. I mean, there's got to be. This is also one of the reasons that I think so much C code, when I open up like C code, is there's functions and there's types that are very, very, very atomic. Like, it's more likely that you would open up C code and see like 50 functions that have 3 lines of code in them than, 20 functions with 10 lines of code or whatever, because because that way they can deprecate, a function and then change it to a new function with the minimal impact to all the other stuff that has to change. How's it going, Slod, on YouTube? You got a Go interview coming up? What? Your first job ever? Wow. I hope it goes well. I mean, these days, if you code Go at all, you're ahead. It's another reason to learn Go. Bloomberg called it one of the 2 highest paid languages that you've never heard of in 2015, along with Scala. And that was back when people were just starting to pick it up. 2015-16, it's a pretty fun article, actually. You might want to read it. Yeah, it's called the 2 highest paid languages you maybe never heard of. And they changed the title. It used to be you never heard of. But it is still kind of expensive. All right, so I need to let me tell you what I did wrong, and then I'm gonna go run in here at 3, and I'll be back later. But I'm gonna write about this. I feel like kind of rubber ducking this out is important. So the first thing I did wrong, that I believe I did wrong, having looked at this now, having had the people on the stream like caused me to rethink my approach, is I overused interfaces. So, and I'm just gonna state publicly why I did this. My motivations were in the right place, but I now feel like it was the wrong way to go, particularly knowing the performance penalty. You haven't written any new C after Go 1.11? It's just a very long time ago. No use cases which I can't do in Go. Right. Yeah, and if you did, right, you could do the C in Go too now. So this interface is going to stay. I'm just going to say right now, the getter and the setter interface is going to stay. But this is what I think. When I did it, I'm going to state it again. I talked about it yesterday. When I did this, I had kind of a weird taste in my mouth. I knew it didn't feel idiomatic. I hadn't seen it anyplace else, but I found it to be a nice way to centralize, what I thought was like an interface. And this is ugly as sin now, because not only am I combining other interfaces, this is a beautiful interface. All right. You'll see tons of single, you sent me a PM. Okay. An achievement unlock. So this is a beautiful interface. This is the kind of interface that Pike would just love. And it's a single method. It can represent anything. You can document it really well. You can write the contract. If you go read the IO Reader interface, there's a quintessential perfect example of how to write an interface. So when in doubt, go look at io.reader. Go look at io.reader or fmt.stringer and read about how those implement. And if you want to see an interface that's been implemented that's bigger, then you might want to go look at, what is it, fs.file. Is that the one, guys? Go doc fs dot, is it file or file type? Yeah, okay. No, it's file info. So file info is the biggest interface I've ever seen in the standard library. Can anybody top that? Can anybody top it, by the way? So, and look through the standard library. There's a lot of good code in there. There's some bad code too, but most of it's really good. So here we have an interface that is encapsulating a structure in a way that exists for one purpose, so that it can be implemented on multiple operating systems. You think, is Reflect really that bad? I almost don't want to look at it. This, up till Reflect, this is the biggest interface I've ever seen in Go. And I haven't looked at the whole standard library, but this is the one it always made me pause. I was like, this is just a read-only interface to an underlying inode. Why don't they just give me the structure, for God's sake? Right? And the reason they don't give me the structure is because they may want to modify it at some point in the future. I mean, this is the universal file info from every single operating system and file system. And by the way, we're not just talking with the FS. If you look at some of the FS implementations, they have file system implementations that have nothing to do with a given OS. So simple interfaces for the win. The bigger the interface, the weaker the abstraction. Ooh, you found Go Proverbs? Oh my God, I love you. I would be totally paying you points right now if I could do that. I would. Thank you so much for putting that in there. Go Proverbs. Oh, interface says nothing. You want a bigger interface, compose it, which is what I did. I did compose it. And that's why I think I probably don't want to do that anymore. I don't think you should compose an interface of other interfaces unless you really need to, and really does not equal, I just want to document all the individual interfaces without stuffing them in a comment inside of this big, huge interface, which is going to be impossible to read later, which is why I did it. So I'm obsessed with the writing of it. This is really nice. So this is what I haven't seen this before. Go-proverbs.github.io. This is kind of akin to, inspired by his talks. Don't panic. Remember I told you don't panic? God, I'm going to go through every one of these. This is great. I got to cover this in a video. This is fantastic. Thank you so much. I didn't know about this. I didn't till today. Now y'all know. I don't see the problem in using many interfaces. But for getters and setters, you can just do func get something. You can, but in my case, it's a little bit different. And we can get into that a little bit later. So yeah, I mean, maybe there's something I'm missing there, but this is an example of an interface that it's probably should be, a struct, but it's not. So but if you look at IO Reader, so IO Reader is another standard interface that if you want to understand interfaces, make sure you understand it. This is one that tells you, it's a very simple interface, but it tells you what it does and what the expectations are and what people who implement it should do, even though some don't. And then we have the stringer interface, which is something everybody can experiment with right away. So, oops, it's FMT stringer more. So this is a very basic interface. Stringer also has some other flavors. So there's JSON.onMarshal, which we'll get into later. This is, no, what am I talking about? Unmarshaler. Has it got one L or two? One. So there's JSON unmarshaler. If you add an unmarshaled JSON, it will do that instead of the reflection using tags stuff. Articles, great articles. I want off Mr. Golang's Wild Ride. I think I read this one. This has been out for a while, right? Yeah. I did. I read this. It's complete bullshit. It's somebody who had no idea. I read through the whole thing the other day. It was a long time ago, but yeah. Yeah. Did they fix it? Because when I read it, it was no, it was just so no. I was like, no, this, no, no. Who writes this shit? This is someone who doesn't know how to write Go at all, not even a little. So I'm just that was my look. You can have your own opinion about it. I don't think it's worth. I don't think it's worth reading, especially because the conclusion is I think they want to go back. Why always Rust? Yeah, no, it's absolute shit. I'm glad you told me about it though, because now I can make a movie about or a video about how it's absolute shit, like point by point. So it really is. They tend to make all these like dumbass conclusions. No, yeah, Rob Pike didn't write this. No, he did not. He did not write this. Is this the same one I'm thinking of, or are you talking about a different one? No, I feel like Rob Pike might want off the ride. I mean, he seems like he's kind of not around as much, but I'm not connected enough to know that way. Yeah, I was gonna say it's uh this is this is actually a really good way to read a bunch of really dumbass conclusions about Go as a Bell Labs fantasy and not very good at that one. Okay, script kitty. No, no, it's so fucking bad. I was like reading through it. I was like, this person hasn't even have the first clue about the premise of writing Go at all. It's just so funny. Okay, so yeah, that's so sad that some people rush to write articles without actually understanding article language. Well, and I made video. I'm to be fair, full disclosure, I randomly made a video one day about Rust versus Go after trying Rust for maybe 3 hours, and the syntax and everything turned me off so bad that I was done with it. And then I started looking at other reasons, and then everybody else started telling me, and then I never did it. And the number one thing people would say is like, how can you bag on Rust when you never have actually coded anything significant in it? And I'm like, that's a fair point, but I don't have to code a significant amount of the language to understand how beginner upkeep is going to be a problem, which you've openly admitted in multiple conference talks. So, I don't need to get into it to be able to know enough. But that particular art, if you're going to write an article that goes into that far and that much depth, then you probably should understand the things you're talking about, because that person clearly doesn't. Um, what makes using an interface beneficial in this case? It just makes it so that anybody can use it and then implement the interface, and it's consistent across the board. So this is where I feel like I went the most. I think this composition of interfaces, particularly these property interfaces, that just needs to die. So I'm going to die. So the new version of this, just so you can get a sense of it, is not going to have any of that. So the new interface that I've been designing, and I think it's going to be, I decided at first time, the first one I thought of was, I was going to do this. At first I was going to say, okay, I'm going to have a very simple interface that has a lot of methods in it. And then I thought, no, that's not the right way. And now I understand that you want at very most, you usually just only want one or two methods in an interface if you can pull it off, because then it can be, because then I got thinking, okay, so let's say hypothetically, if I do this interface like this with multiple sets and gets and read and write, right? First of all, what is the purpose, right? The purpose is for me to tell other, applications, hey, I can fetch a thing from this, right? But by doing it this way, if somebody wants to implement the map interface, they have to implement a getter and a setter. Well, what if I have a read-only thing? What if I have a struct that provides configuration data that I want to add a method to so that it's compatible with things that just want to fetch that data, like in a unique way that I don't know the key in advance. People on YouTube and other places have been suggesting to just use successors using get name, etc., which, by the way, is not idiomatic Go. Let me just show you something that's idiomatic Go. If you're going to write an accessor and a mutator, in other words, a setter and a getter, then a getter and a setter, and then you should do the getter without putting the word get in it. And you should use like that file info. So the file info is a great example. And you should do, let's see, fs.fileinfo. and you should, and the setter has the word set in it. So this very idiomatic Go. It's not one of the things that they cover very much. To the tune of Apple Pen reader writer. We need to go play that. Can we please play that? You can write something like this for any language. Yeah, you really can. We're reading another like Slammer thing. So this here is a getter. This is the proper way to write a getter in Go. Right? You put the attribute and it's a function call method, and then you can use this for what I call I don't know. They're not dynamic member attributes or attributes. In other words, this is a name. I have one called path. In other words, it's composed of other stuff, being combined together. But if you wanted to make a setter for name, the idiomatic way to do this would put the word set with a capital S in front of it. That's the idiomatic way to make a setter and getter interface if you need one. Most of the time, you just go straight to the struct, and Go programmers are much more likely to give you direct access to the underlying struct values than they are to write an interface. Writing unnecessary setters and getters makes Go people pissed off, and I'm with them, because that's one of the things I hated about beans. Oh God, does anybody remember Java beans? Does anybody remember this? I mean, I imagine a lot of you were fortunate enough to not know about it. Thank God. It was just so fucking bad. It was indirection for no sane purpose. So I'm going to actually rewrite this. So here's my plan for this interface right now. So I'm going to do type setter. And by the way, once I do this, guess what? Anything with a set method fulfills this interface now. It doesn't have to have all of the other shit. So I can say set, and you're like, well, why would you have a set interface? Well, I have a key value pair combination, and I don't know what's on the other back end, and I really don't care what's on the back end. And then I can do set key value strings, and I can say atomic and automatically persisted. Now what I can do this is I can, instead of putting some random comment there, I can make, setter implements, implements a set method that atomically and automatically persists any this is any new values in a way that is not only safe for concurrency, but uses established best practices for file level locking when persisting to file systems, etc. So this is something that doesn't exist in Go, and I'm going to make it because I need it. But here, the point I'm trying to make here is that this isn't actual Go, it's just a note. Yeah. So the reason I'm making this is I want to have a lot of implied expectations when you implement my conf.setter. If you implement my conf.setter, I expect you to do things atomically. I expect you to do things, persistently. And this is going to mean right from the get-go that if somebody implements my conf.setter interface, they're going to go read about it, and they're going to read about conf.setter. There's going to be a link in it, and they're going to read about that so-and-so's application or struct or whatever implements conf.setter. And that means right away they can see, oh, this is going to have a higher latency. So I can say things like this: higher latency should higher latency requirements should generally be expected, since every call must persist immediately. So this is why I like interfaces, because if someone's going to call, why would it even call a set, right? Well, it might be talking over the internet. And we talked about Cobra yet last night about how Cobra got kind of tanked because there was so much latency built into the system, but there was no communication of what Corba calls were actually network related versus like really efficient, locally. So the reason I'm putting this warning here is that if somebody's going to implement the setter, that means this thing could be swapped out. It might be super highly efficient right now. Maybe it's going to call set against a file. Maybe it's going to call set against a tempfs. Maybe it's going to call it against, a remote HTTP thing. Maybe it's going to call it against the SQL instance that's running. Maybe it's got a running Postgres database that's running. It doesn't matter. You can implement, anybody can implement comp setter and persist their configuration wherever the fuck they want. That's my point. That's what I want. And because I am sick and tired of dealing with everybody's different version of configuration, including Viper. That's what I like about gRPC. Absolutely. So gRPC is like, you could implement gRPC as a method to do set and get, right? Because it's built-in persistence. You might just be able to use gRPC period, right? But I want something more generic than that. I want to be able to put together utility and implement a setter and implement a getter, right? Which is the other thing. And then I want to be done with it, right? So, and rather than have it all in one, I'm going to take down the getter here. I'm going to do this instead. So I'm going to say type getter. So this is actually the type name here is conf.getter. And I love that because that implies, well, do you use a conf.getter? And I'm like, oh, what's the purpose of a conf.getter? Oh, it's this kind of universal way to fetch configuration data from any source, with latency built in. In other words, it's kind of got a latency expectation. So when you see the type conf.getter, that should convey immediately, oh, it's a thing that is going to go fetch a configuration variable from any number of places, which the fastest possible method might be from disk, but it could be from any number of sources. Oh, that's what conf.getter, right? As opposed to using just a map or a context. I actually really seriously thought about using context for some of this, but there's no reason you couldn't use context to do an implementation of a struct that fulfills the getter interface. So you can pull that off if you want to. I mean, and this seems like overkill, but this is a thing. It's also something that I think I'm going to be able to use as a basis. I mean, I've been talking kind of in a long-winded way about this whole conf-go project, but I think the conf-go project is really going to help me convey why interfaces matter, because I'm going to implement multiple structs that use this, that implement persistence in different ways. There'll be a toml, whatever, we're going to figure it out. There'll be structs. Some of them are going to be built into the conf-go library itself. So we'll have a standard JSON persistable file. We'll have, standard XDG. We'll have the standard, properties files, and you'll be able to go back and forth between those using those structs. And since the interface is there, you should be able to transform, the one into the other one. And that then becomes, as long as it has a getter and a setter, the problem with that is if you're going to do a transformation from one source to the other, about unknown interface, or happy about generics. I have mixed feelings on generics to this day. I'm gonna have to reserve judgment. I go back and forth. I was really mad about them when they came out. I was like, we don't need this. And then I really dug into it, pretty deeply for me. And, there's been a lot of really great work done on it. And when the generics final draft that I saw, they were not even using angle brackets for the templates and stuff. They were using parentheses instead of square brackets. And I thought I was going to lose my mind. You will not believe, you thought signature lines were dense and with reverse notation and Go before. When they were doing interfaces as parentheses, you could not read the signature. You could not read the function signatures and stuff. It was insane. And then they went to the square brackets and it got better. They're going to get misused. Yeah, that's my number one concern. They're going to get misused, just like anything. Interfaces are getting abused all the time. They're getting misused too. If you give somebody a thing, they will misuse it. It's like, and then they said, but not everybody has to use it, and everybody has to learn it. That's the biggest fucking lie. I'm so tired of hearing that. The only people who say that are people who don't ever work with people who learn how to code. And I'm gonna rant a little bit about that. So this is a Go stream, so I'm gonna go ahead and rant about it. The people who use the argument generics don't matter for beginners are wrong. They're just wrong on so many levels. How many beginners have been burned by all the mod shit that's been happening? Right? Am I going to use generics when I need them? Yeah. There's a couple of times when I might, but I've gotten pretty used to untyped interfaces in case the generics will probably be faster. I don't know. Than you can probably benchmark it, but I don't want to. Then type switching with case statement. I actually like type switching. If I'm gonna, first of all, I don't like loosey goosey signature lines. This isn't fucking Python or PHP. I don't like loosey goosey signature lines. I never have. I mean, this is why we have interfaces. This is why we have the untyped. If you're going to use the untyped interface and a variadic function signature argument list, then you're trying to make Go into Python, and there's reasons to do that. FMT println, for example, printf and all that. I mean, there's reasons to do it, but if you're doing it because you don't want to make a decision about long term about what your function should be, I think you're doing it wrong. I think you need to think more like a C coder at that point, personally. But I am not, I am not the end all language developer. I just like really, really clean code. I mean, I'm the guy who will spend all this extra time to try to make clean code and not fucking finish anything. I don't finish anything. So, because this is for this reason, right? So I think that people are going to, the argument that beginners are not going to be affected by generics because they don't have to use them is a lie, because people are going to use generics. And if anybody who's been around beginners at all knows that beginners learn best by looking at code. Where are they going to go to look at good code now? They can't go to the standard library to look for good codes because it's all fucking full of generics. I mean, what I'm predicting, I'm hoping it doesn't happen this way, but I'm predicting that as soon as generics come out, just like context, how long did it take for context to infect every fucking function in the standard library? I mean, somebody decided context was the way to deal with the problems that context solves, like concurrency and communicating to middleware and, cleaning up and timeouts and all this stuff that contexts are great for, right? There's other ways to do that, but they didn't consider those as far as I know. And I don't follow the team very closely, and they're good people, but they made a decision about context, and then they'd used it at Google for a very, very long time. And then overnight, everything had context in it. Yeah. Hat tip to your mom. They should have named it context.c. I think they should have, but they didn't. And they shut me down for even suggesting that. So the thing that bothered me about that is how quickly this optional thing became mandatory learning. You cannot do any middleware or HTTP programming, which is pretty much Go's sweet spot, without knowing context fully. If you don't understand, and try to explain context to a beginner. I still get it wrong. I finally think I start to use it. It's like this pin in this hand grenade that you can pull out and it will blow up everything that used it up to that point so that it doesn't affect it. It's so hard to make metaphors for how to use context effectively. And frankly, Pike, it's not behind it, but he's used other metaphors for how to, things that are not particularly intuitive. Feature will get there, use there, and there's no way to escape it. So look, there are many reasons that I think generics are needed, and they need to come out, and we need to see it. Unfortunately, we're going to have to just deal with it. If for no other reason, then a bunch of other uninformed programmers are going to think that it makes Go real, because you can't be real unless you have generics, which is just such a fucking stupid, asinine, base thought. I can't even begin to say that. You don't have to. C's proven it over and over again. It's like, not to mention, it's just so stupid that it's not a serious language unless they have generics. It's so fucking idiotic. I mean, how many languages are there that don't have that? BG songs from? I don't have a song right now, do I? Yeah, my songs are off right now. But yeah, they're on my Spotify. You can go get them from there. So given all of those things, I'm just going to say that I'm hopeful But stop telling people, one, that you can't have a serious language without generics. That's a lie. And there's many languages that do. And two, that beginners won't be affected by generics. That's a lie. Because they'll do what beginners do. They will look at code that's from the standard library. I mean, for example, let's take for instance, this role play. There's going to be the other one too, is that we need generics in order to have map filter reduce, which I just laugh my ass off at that every time, because Pike made a blog specifically about why there's no map filter reduce in Go. He's like, just use a for loop. Seriously, he was like, why do you keep asking me for map filter reduce JavaScript script kiddies? And it's like, this is Go, this is, closer to C, this is not your fucking JavaScript or whatever. And, but it is part of, functional programming and stuff, blah, 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 blah. So, so it's kind of a less thing, but people who are pro generics are like, well, we're going to get map filter reduced now. The better way to say that is we're going to be able to do complex computational data structures and algorithms that are not possible without generics. And that I do agree with. So I've done a rooted node tree, and unless I use the untyped interface, I would love to be able to do a rooted node tree and say, this is a rooted node tree of this specific type, and be able to implement the whole thing and have the entire thing implemented in a different type. And that kind of thing is what generics are good at doing. And that there's a lot of, computer scientists who are gonna really love having generics, because in a strictly typed language, unless you have that kind of escape hatch for that kind of thing, it's hard to create. C++ uses templates, of course, for all this. And templates are not generics. They look similar, but they're not the same. I suggest Googling parametric polymorphism. Yeah. Type flexibility of compile time. Yes. Yeah. And the other cool thing about it is that's actually the best. It's type flexibility at compile time. So the untyped interface, which is just a nothing, right? Is an alternative to generics, but not really, because why? Because you can't even use the untyped interface without runtime hits, because you have to switch on the type at runtime. At runtime, you have to switch on the type. So you write effectively the same code as you would with generics, with not really though, because then you have to have a big old switch statement that switches on all the possible types you can take, which I actually don't particularly mind if I'm going to open up my, variadic function signatures, with argue parameter signatures to have that shit in there. But I normally wouldn't do that. I would normally say, hey, I want to compile, this thing for this type. And so in that sense, I'm kind of pro generic for that. But the biggest complaint I have about generics is related to something that I've had to get over. Go is not a beginner language. It's not. Go is a super friendly language. It's much more friendly than Rust, hands down. It's more friendly than even, C++ and some of these other languages. It's definitely more friendly than Java, in my opinion. It teaches you encapsulation and positive, solid principles without forcing you to do inheritance and shit that Java would do. There's a million reasons that I like Go for beginners, but I think the reason that I was having such a hard time with generics is that generics definitely, I mean, messaging already kind of did this, right? But it definitely puts Go out of the beginner scope. It's no longer for beginners at all. And which, is something that, people, Rust fans are, most of the people that have come to Rust are coming from JavaScript or something like that. The people that I've read and heard and watched, they tend to already be pretty advanced programmers. They say Rust is beginner friendly. It absolutely isn't. But to the the Gamozos of the world and to the people that really know their shit, it's a great language because they can navigate it. It does what they want, but it's an advanced language. I mean, Rust is an advanced language. Let's be real. So is Go. Go is not as there in terms of advanced. I mean, difficulty to learn it, right? And so my gripe with generics has always been it pushes the language away from beginners in a big way. Modules did the same thing. Boom. Context, boom. Every single time there's a decision in the Go directional community since the first version that I used, which is probably like 1.7, when Rob Pike came out. It was super sexy and plain and all this. Um, it seems like all the decisions are pushing the language to make it more powerful, and they're pushing it away from simplicity. And that means beginners can't get into it as easily. And I've always been dealing with beginners, and that's pissed me off. Every single time that that's happened, it's pissed me off. And I've just had to finally accept that Go is not a language for beginners. And if you ask Rob Pike straight up, he's like, no, Go is a better C. It's the best second language to learn C first. Every single one of the people who were involved with that, with Go to get started, never considered Go a first language. They said it was a junior or a beginner friendly language meant to kind of fit in the same space as Python mostly, but it was never intended to be a beginner language. And every single decision that's happened since I first started, it has pushed it away from beginners. And that angers me because I love it. I love the language. It's got a lot of really advanced, really amazing things. And, garbage collection, people shit on garbage collection all the time. I'm like, no, man, that's what makes it great for beginners. It's got garbage collection. Beginners should not have to deal with garbage collection. That's why I like the language, because it's kind of got that attraction for beginners. And it's just going to be a matter of time. You can only turn GC off and Go, right? But the way that I don't want Go to start chasing C++ and Rust and shit. I don't want it to start, and I feel like the generics thing is kind of that. It's like, oh, we've got to have generics or we're not real and all this. There's just a million reasons that I feel like it doesn't need to be there. Bottom line. So, that's not a problem. Go will be backward compatible also with generics. Yeah, I don't. That statement is so categorically incorrect when dealing with beginners. I can't overstate it. So this is so somebody on Twitch, I won't say who, says that that's not going to be a problem with Go because it's backward compatible also with generics. So that argument is usually made by very advanced programmers who don't deal with beginners. And the argument is beginners don't have to deal with it because they won't have to even look at generics. They don't have to use generics if they don't want to. The people who make packages and libraries can use the generics, and that complexity is all hidden away for them through the magic of, package encapsulation. And I don't buy that for a second. And the reason I don't is because the way that I help beginners learn and the way that I learned was by reading packages from the standard library and other really great packages on GitHub. And guess what those engineers are going to use as soon as they can use it? And I made this point about contexts. How long did it take every fucking network related package to have a version that has context as the first argument? If you don't think that the standard library is going to be infected with generics everywhere within one release, I think I hope I'm wrong. I hope I'm wrong. But if you start to do that, then the ability for beginners to go to the source code to learn how to code has been diminished. Sure, they don't have to use it when they start. They don't have to use messages or Go routines or any number of other things that the beginners don't use already. Or even, some of stuff. They don't have to use that. That's true. It's true as a beginner. But every time you add complexity to the language, I think that the standard library is going to become more convoluted, and then the ecosystem is going to, why the fuck have generics if you're not going to use them? Right? So now you've got everybody using them. They already implemented them in standard library for something and it boosted performance. I'm not saying that it won't boost performance. That's not my argument. As again, my argument against it is one that I've kind of backed away from. It just makes the language less approachable to beginners. And the answer almost every time to that is, well, it's not really a beginner language, one, or two, it's not going to be that complex. They don't have to use them if they don't want to. And that's and to me that's an uninformed opinion, because that's somebody who's suggesting that they can learn Go without looking at the existing source code. Well, they just, if they stick with the beginner books, what beginner books? Show me one beginner book that's consistent that covers 1.17. There isn't any. There's none. So the part of the problem I have with the Go ecosystem is that the people who are coding in Go, first of all, they're really busy, and number two, they don't give a shit about beginners. They give a lot of lip service to beginners, but they really don't care. And in fact, one area that Rust has kicked ass against Go is the wooing of junior beginner programmers, which is really ironic because Rust is not a beginner language, but it has better documentation. It's got better books written for it, from what I've seen. It has the lie that it tells them that you're going to write safe code. You don't have to know about memory performance and garbage collection. You don't have to know anything about that. You can just write code and be fine. And the culture in Rust is, I've been told straight up by somebody I very trust a lot, who brought Rust to my attention first, and it's now got a job at InfluxDB, that the Rust community was way more welcoming to him than the Go community. And I have a feeling that's because the Go community is a little more C-like than the Rust community. I don't know the reason. I feel like the Rust community is kind of cross-pollinated with the Node community a lot. Because async comes to mind. There's lots of reasons I think people are attracted to the language, because it does feel a little bit like Node when you get into it. I mean, at least asynchronous stuff does, the model they went with promises and stuff. So I don't know. I feel like I don't know. I feel like, suggesting something like the way when I suggested context.c just to simplify the interface to make it a little bit easier to read, with the idea of a beginner coming to it, that just got shot down, and they just did not give a shit. And it, it's not completely fair. I'm sure there was some people that really were bad into it, but I just said it to make you happy about them. What's that? Oh, the boosted performance for generics. Yeah. I look, I have no doubt that generics are going to boost performance. That's not my complaint. And by the way, this whole little thing that I've just said about Go generics, to me, it's about me. It's not about them. It's not even about generics. It's about me. I have to change my level set about Go. Go is not a beginner language. You know how hard it is for me to say that? It is very hard for me to say those words. It is super hard. I don't like saying it. I don't like saying it because I want Go to be a Python replacement, and it's not. It's not. Go is easy, but you've already been programming a while, right? Everybody that says Go is easy, they've already been coding for like multiple years. And I'm talking about people, I've dealt with 10, 12, 13-year-olds who are coming to programming first time. And Go is pretty damn easy. It's a really great way to teach pointers and stuff without the toughness of C. But, it's not as easy as Python to pick up. Or as JavaScript, for God's sake. JavaScript and Python are much easier to teach to beginners. And Go is almost there. That's the thing that bothers me, is that Go is almost easy enough. You decided to learn about your Go because of me? Best decision ever. Was this your first language that you learned? WMW? I'm just curious. Would you mind letting me know? Go in action is full of material, factual, objective bugs. One of which I had to write my own errata for. It's not good. If you get Go in action, make sure you look up all the bugs in it. So yeah, there's like straight up, not just bugs, there's like fucking, their code won't even compile in some places because they used the wrong identifiers and switched out with different ideas. It's absolute shit. I'm sorry. I like the people who did Go in action. I like the people who published it, but that book is shit. It's absolute shit. There's a couple of things I picked up from it, but I was so pissed off. I could never recommend it to a beginner. Headfirst Go is ancient. It's very nice. It's got a folksy approach. I love the headfirst approach, but it also sucks because it's so fucking ancient. That covers what, 1.8? It doesn't even have anything about modules in it at all. There is no beginner book that I would recommend to anybody right now because Go is in such transition right now. You can't even lock it down. And this is one of the things about Go I was hoping would never happen. Go is, in some sense, it seems like it's trying to channel Node, where it has that, JavaScript, it has a running release every 2 months or some shit. And I get that they want to improve the language, but how are you going to document the thing or teach it to anybody? All the stuff is like out of date. So, and now they're going to add generics. I would not buy a book about Go at all. I mean, unless you're already coding in Go. There's a number of really, Alan Donovan, there's a number of really, really great Go books out there that are not for beginners. Learning Go is one of them. I'm only about 230 pages into it. It's like 500 pages, but it's the one that goes into interfaces and returning structs. It's sort of opinionated. And I like that, but it's not for beginners. It's not for beginners by any sense. It doesn't cover modules at all. It doesn't talk about setting up VI at all. It says go download Goland and go for it. Um, it's whatever. It's fine. I mean, I don't know. Vim and beginners, they don't go together in some people's brain. I forgot the book name. The Nathan Youngman book. Is that the one? I don't know. So this is my conclusion. My conclusion is I no longer recommend people learn Go. I never really strongly recommended Go as a first language. I never did. For me, it was always, for years, I taught, for 5 years specifically at JS Skill Stack, I taught Python as the first language. And then I started to create language bigots who didn't want to learn any other language for whatever reason. I don't want to get into that. And then 2, I started teaching JavaScript as the first language because I could teach a lot of amazing computer science concepts, and because it has first-class functions and fat arrow functions, and you can set up functional pipes, and it's a functional language in addition to being a regular, kind of other. So I taught JavaScript is an amazing first language if you want to pick up a first language and you want to be empowered. It is. But if you want to start understanding how your computer works, there's no better language than C. And I've been told for the last year and a half since I started live streaming, I've had very respected people, some of whom are higher up in the technology world, in terms of executives, or they're in training, or they're making decisions. And I've had a number of people recommend that I start teaching C to beginners. And I covered about this the other day, but my decision about Go is I will no longer even consider teaching Go to beginner. And I'm going to start teaching a very shortened version for comprehension to beginners, because look, my goal is to be able to teach C to beginners in a way that doesn't confuse the shit out of them, and have them just understand how the computer is working. You wish it didn't have GC, well, but if it didn't, you might wish that, but you understand if Go takes GC, you can turn GC off, by the way, you know that, right? It's like nobody knows this. So you can disable GC if you want to in your program. But so you have to do it at compile time, but yeah, that's the thing you can do. Most of the people that say they don't want garbage collection though, for CLI tools, I'm pretty sure. Yeah. Yep. You can minimize it for sure. For systems programming. Yeah, I'm almost positive you can, because they do that in the Go Tiny project, I think. Actually, Go Tiny is a different implementation of the whole Go runtime, I think. Yeah, I don't know. They definitely do. There's Go out there that doesn't have garbage collection in it, for sure. You can definitely turn that off, because all the tiny stuff would die, right? But generally speaking, if you think you want to take garbage collection out of a language, out of the runtime of a language anyway, you usually, in my opinion, you're making another decision at the same time. You're like, if someone were to say, okay, but the syntax has got to look like Rust, even if they cleaned up Rust to the most beautiful syntaxes they possibly could, if you take garbage collection out, who's going to do the garbage collection? It has to happen at runtime. Who's going to do it? You? And then you might as well write it in C, because now you're doing your own memory management. And God knows what happens when you do that. People bag on garbage collection all the time. And at the same time, they'll bag on, oh, this isn't safe for memory overflows of shit. But the garbage collection actually makes you safe from those memory overflows, because it's taking care of cleaning up the memory without one-off errors that you would write in your own code to do the memory cleanup. So you might say you don't want garbage collection, but you probably don't mean it, because you don't know what the language would look like if you took it out. And if you want an idea what it would look like, look at C or Rust, because those are your options, and you're going to add complexity in a way that's going to make your coding day not fun. So you're like, man, I wish I didn't have garbage collection. I wish I could have this awesome syntax, this nice minimal syntax, and also not have garbage collection. No, it doesn't happen that way. The reason garbage collection exists in runtime is because it's doing your job for you, rather than having you write it all out in longhand, which is what Rust is, or having you, do it all yourself in C, and then making tons of programs. So, have you heard about Go script? Another way you could get rid of garbage collection, you can write Go code that doesn't use garbage collection by using arrays directly. Nobody knows this because they don't do it. But you don't have to. Denial of service probably knows about this. But you don't have to use the structures that have garbage collection built into them in the first place. So like if you use arrays and you put more stuff on the stack, as I understand it, and then you would have less garbage collection, period. You wouldn't be messing with a heap. Even though the heap, I don't know if you can disable the heap entirely. That's something that we need to read about. We definitely need to read about that. That would be super. That's something about you know what? There's just not enough time. I would really, 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 really love to just sit and read all of the runtime code. I've read some of it, but particularly the parser. That's not runtime. That's a compiler. Never mind. But I would really love to just read the runtime itself and see why they do it. And because there's a part of me that still wants to make a language at some point. I've written my own, pagan sub meta language and used the functional parser built on, primarily inspired by the Pandoc parser in Haskell. It's a functional parser, but I would really like to do the next step, by writing the compiler and doing all that kind of stuff. Yeah. I have some time. I've got to get my interfaces for my stupid fucking conf-go first. All right. Besides, it's almost 3 o'clock. I'm going to go do my run. Let me read here. Have you ever heard of Go script? You can totally do that. You can do Go script. Yeah. You can use Go as a scripting language now. Yeah. Have you ever seen it? Go read the blogs about that. Yeah. There's tons of blogs about that. You probably missed the bug report because I don't know Golang, but maybe this is the one that tries to address interfaces called penalties, heap versus stack. It is currently in the backlog and reference a lot of other problems associated with it. Command compile, escape analysis on interface calls. As interfaces are widely used in the language, it seems quite important to be able to perform such optimizations. Shit. Look at you go. Thank you for finding that. Thank you for finding that. Oh my God. This is awesome. This means that they haven't forgotten about it, right? Of course they use the context for it. Of course they do. Context allocated on stack as call method was empty in my case. This is great. I'm going to follow this issue. Watch. Did I already start it? I already had it started. How did I already have it started? Is that because I clicked on watch? I think I already had it watched. Shit. I did. Wow. Wow. Maybe it was in the URL. Who knows? Yeah. That's cool. I gotta read that. All right. So the other part of my interface. So I'm breaking it down to a getter and a setter, and I'm going to write the instructions up above here, and the reader and writer. Guess what? I don't need it anymore. This is the craziest thing. I don't need read and write. No, because when I do a get, I do an implicit read if I have to. It's basically I'm writing my own hashing algorithm. That's what, when you add set and get, this whole conf thing is like a meta level hash algorithm. Every struct that implements it is writing its own hashing algorithm, which is kind of cool to me because then I can make the comparison. So what I do need though, so who is going to use this? How do they want to use it? What do they want to use the data from it? So the other one I want to do is I want to do type mapper. And yes, I'm going to iterate. So I'm going to have a map. And then I'm going to put a conf dot function is going to be a map function, a map func, and that is it. And I guess we could have an error. We could spit out an error if we have one. And so, because there's really, again, we're talking about, just all a mapper does is it just, I called it filter originally, but it's actually more of a map. I'm thinking about Perl maps more than anything. So it says, give it a function. So then you have to define a function type. So let's type map func. The map function type is a a func that takes a key, comma, value string, and it returns a key, comma, value string. That's it. That's it. So a map function just returns, and then I can write up the type here. I can say returns empty key if return, I would say return empty key to ignore empty values will be considered new value. So this is what's up, and that's all I need. That's actually all I need. I got thinking about it, and I was like, man, that's really all I need. I just need to be able, if I have a mapper, I can like create, structs and everything that list all of the configuration values. I can have them go through the configuration values and eliminate ones that are duplicates. I can have it do any number of things. We're talking about keep very simple, string things. And if I wanted to make an importer, I could say, I could make a function that imports from one to the other, right? So yeah, I mean, if I wanted to make a translation layer, but I don't really even need an interface for that. I don't need an interface for that. I could write an interface, I could write an interface that does, that, is like an importer or a transfer or something like that. And it takes in one and sets the other one, right? But I already have that in map. Yeah. I guess you could call it a transposer. I'm just playing, but if not transposer, what would be a migrator? Migrator, a copier, a duplicator, migrator. And then, we could call it a duplicator. How about that? No, we could call it a syncer. We could call it a writer. No, we could call it what we wanted to do is write to the other one, right? I could say overlay, overwrite. How about that? Overwriter. I'm just playing. But if we had, you could say overwrite, and you could have one getter, a conf getter. So we'd have from conf.getter to from to and conf.getter with an error. And so yeah, so this would say take all the values of from and send them to, and then you could implement it however you want to, but you'd have to have the override function. And that would allow you to combine you could use that to do all kinds of combinations stuff. But you don't have to implement the overrider, right? That would just be one way to implement it. You could just say, this is what I'm going to get. Actually, no, it would be from needs to be a getter, and to needs to be a conf.setter. And if I have a conf and a to setter, then I can take it from the one and I can set it to the other one. And I'm going to use the interface, which is not going to be fast. There's no way that's going to be fast because we're going to have two interface calls with indirection, which is going to do this. It depends on the memory thing related, but not too much memory. And then we're going to be, it's going to be function calls to transfer from one to the other. It's going to be, it's not going to be really, really fast, but this is designed to be operating on two very disparate systems. So let's say you write a getter and a mapper struct implementation that fetches from the internet, and now you want to make one that writes to a file in JSON. Well, if I have an overrider interface, I can make a struct that does the translation. I can say, okay, I want you to read from here, and then I want you to write to this other thing. And as long as you have a getter and a setter, you can read from things. That means I could encapsulate resources on the internet that are read only. So say, I don't know, weather API or something, and then I could make a conf getter It's not a configuration source though. I mean, that would be kind of the whole. I've thought about renaming it instead of having it be conf, having it make it be something else, but I don't like that. I think I want to keep it configuration related because I don't I don't want the scope to creep beyond fetching configuration data. But this does mean that I could put a configuration file on a remote system, and I could configure things locally, and then make a cache. I can make a cache of the remote configuration by saying, okay, I want to download this thing, and then I want to overwrite, this other setter, which is a struct that's a YAML file in this current, it's a YAML file configuration struct that uses a localized file system structure, and then you can make any number of structs that have all kinds of different ability to translate back and forth between the two different types. So yeah. And that would be the extent of my interface. So then I can kind of drop this other stuff here. I don't need this other stuff at all. I don't need to load the state and overwrite memory from the source persistent state. That stuff is all kind of gone. Because why? Because persistence is automatically built into set, and concurrency safety is already built into the set and get. I don't need the rest. Map is automatically got concurrency locking for the entire function of the map. So I can say you need to lock the state of your entire thing needs to be locked while you're mapping, and then you can unlock it. So this is cool because this gives you a transactional ability to transform a given key value pair set into something else in a way that's safe for concurrency and persistent. The problem with this though is that, well, no, I take it back. It doesn't care about the implementation. So if you implement a struct that's going to implement map by iterating over the internal map, then you're fine. So you don't get the performance by having to call some set or get in there, right? You can. So, but the reason that the map func definition is the way it is because I don't want to burden implementations down with calling another API. I don't want to make them say, look, you've got to be using the setter and getter on these key value pairs. So that way, if somebody wants to implement a struct that just like screams through a map string, they can do it, and then they can just lock it for the transformation, and then come back. And by the way, you can use this map func as a closure to put in a value, that you want to like mine out the data. You can construct new, primitive structures or other things like that by putting them in your func by using closure. And so this is a very flexible way without adding a bunch of extra complexity. So we just have a setter, you have a getter, and a map. And if you want to overwrite, then that means your implementation is smart enough to translate from one to the other. This, however, is going to use the method calls, and it's important that we talk about that because you have to, because you're passing a getter and a setter. You just realize that RWX means read, write, execute. That's one of the meanings. It's got many, but yeah, read, write, explore. Yeah, it's kind of a play on words for many things. I'm going to say goodbye to all y'all. I'm going to go run before the sun gets too far down. It's not cold here yet, but it's more fun to run when it's a little bit warm outside. That's going to be all for me today on the conf-go. That's quite a bit to talk about. To the YouTubers that are out there, welcome. I won't be streaming to YouTube further today. I'll be doing stuff. If you want to come over to Twitch, you can come over there and listen to the music and watch it there. But the reason for that is because I'm going to be using music that YouTube doesn't like. So, I'm not going to be using music right away because I'm going to be listening to it on my phone while I run. But after that, if you want to come back and hang out, welcome to the machine world. What's that? I'm not sure if it's by him, but he just found a peek. Just took a peek and found out that a user called Rob Pike on GitHub. He's still actively opening issues on Golang Go. The last one was a few days ago. Yeah, he's definitely active. He's just not, I don't think he's as active in the design decisions as you, I don't. There's no way I could know that though. So please don't take that seriously. In the last couple of years, the amount of contributions has declined. Yeah, absolutely. That's my point. That's my point. Pike, Grissomer's off the project. And Thompson, I mean, Thompson was kind of there for namesake, I have a feeling. Because, Ken Thompson from, Unix land was on the project. So Ken Thompson, Rob Pike, I think Pike was kind of the lead. I'm going to get in so much trouble by saying that. Somebody's going to watch this and they're like, oh my God, why did you say that? Sir, can I ask a question about my code? No, not to me. You can ask a question to anybody else here, though. What does Rob Unite? I don't know. I think he's, I don't know. I don't follow him closely. I probably should. I'd like to meet him. He's my kind of asshole. He's also learned to be very stoic and very controlled, and he's married to an artist just like me. I'd probably get along with Pike a little bit. He'd probably hate me though, because I probably don't meet his criteria for excellence. I literally have dreams of having a beer and smoking a pipe with a bunch of people that I really highly respect, including Rob Pike. I do. I don't have sex dreams anymore as much. And that's not like I'm having sex with Rob Pike. Please don't go there. But I have, when I have really positive dreams that I wake up and I'm like, oh my God, I'm not aroused, but I'm just like so happy, it's because I'm like hanging out with Aaron Schwartz and Lawrence Lessing and Rob Pike and Ken Thompson, and we're arguing about and Larry Wall, and even Guido Van Rossum and Brian Ford. I mean, these are TJ Hollowaychuk, which is a pretty weird crowd. Can you imagine putting all those people in one crowd? I would pay so much money to see all of those people just come together and have a beer and just talk about tech in the world. I would pay so much money for that. If you could put all those people in one room, if Richie was alive, it would be even better, right? Can you imagine all those people being together? And yeah, I mean, we probably invite Gosling just to make fun of him. It's a joke. It's a joke. Don't freak out. All right, so don't forget Pottering. Yes. And if we could get Grace Alper, if we could go back in time. Speaking of which, I want to run an idea by y'all before I sign off for a while. So I've been reading the Innovator's book, and I've been starting to think about having Sunday story time. And I don't, where is it? It's not here. I've been thinking about maybe having a Sunday story time where I actually read to you from the Innovator's book, and we just talk about it. It's so, because yesterday's chat, I don't know who checked in yesterday, but last night for probably 3.5 hours, I was in just chatting, and we were talking about quantum mechanics, and it was amazing. I don't know if you saw when I started the stream, but I had a bunch of stuff up from the CIA dossier documents that have been released for, it's fucking me. So you're going to see me streaming a lot more in just chatting. And some of my just chatting streams are going to be related to recent documentaries I've seen or conversations that we can have. This meeting would revolutionize the world. And I think one of the things of just chatting that I could do would be to just write a chapter and just discuss, because the amount of contributions that came into that stream yesterday from people that were like well informed about the topic just blew my mind. They're like career scientists and chemists in the room, and they were able to, virtually, and they was talking about their take on it versus, because the biological application of quantum mechanics, like the quantum robin that you clever its eyes and it can't navigate because it uses photonic entanglement inside of its brain to trigger the magnetic stuff that it's already in its brain to sense so it can navigate. It's just fucking amazing stuff. And everybody was just, they had a pointed discussion about it. I was just really blown away. And it's not just to geek out, but I just think it might give us a source of conversation that's a little bit more enlightening than playing Dota or Witcher, which I love too. I love those two. Was average online higher? What are you talking about? Was the the number? No, we had like we had like 40, 50 people and just chatting. Yeah, I couldn't believe it. I mean, the lowest it got was down to like 17 or 18, and we picked up some new people. I mean, again, I'm not doing this for the likes and subs. That's not what I'm doing. I'm doing it for the exchange. I was so just, I don't know what the word was. I was just kind of electrified by the conversation to the point where I forgot I was just chatting. We sat there and had this amazing conversation for. I mean, this whole thing has been kind of, spun off of that whole Rob. I'd love to have, beers with Rob Pike at some point. But the quality of people that are participating anonymously in the chat, in the Just Chatting channel, when we did that the other night, was every bit as high as. I mean, it was really fucking amazing. I was like, can I please record? I'm really happy that all my chat is actually being written to a log. And this is yet another reason, by the way, that I'm trying to get something new that's not built on Discord or Slack or anything that's proprietary, or, so that I can have this log, this database log of our conversation, because the people that were participating, it was amazing. We covered the JFK assassination. Somebody talked about the theory that the shot came from within the car, and I was like, oh my god! And it was just so amazing. It wasn't just conspiracy stuff. It was actually really, really fun. We talked about yoga for like 40 minutes, because anyway, I'm like, running is yoga. Speaking of which, I gotta go do that. Go Twitch IRC. No, I'm using I'm just using WeChat, WEE chat. It's a BitChex sort of faithful replacement that uses IRC from the command line, and it's on all the time. It's in a pane and it's like writing to it. So I need to make a proper bot that is actually logging all the time, even when I'm not logged in. And I want to obviously bridge the other chat, and I've been trying to decide what other chat that would be. It'll probably be Matrix. Matrix is the project. The Matrix project is so amazing. So far, it's been so amazing. I might, you know what? Too much to do. I can't believe tonight's Sunday. I'm probably not going to be able to do much more tonight, because my wife's going to come home and she did her huge mural. It's her final project. And I'm going to want to talk to her about that and spend some time with them, my family and stuff. So I don't know how much I'll be back online tonight, but just to let you know. So I'm going to go run. Get outside. Go outside if you can today. I'm going to give you that challenge. Go outside. Enjoy the air, even if you don't do anything else except for stand there and take in the sun and the air. And then you can, if you want, you can. I've been thinking about putting my stuff public, but I don't want to, because then you know I was running and stuff. That's pretty fucking dangerous. So I'm not doing that. It's just too many potential problems there. Bye. It's good to see you. Particularly, so by the way, so if you want music, I'm gonna leave. There's gonna be no music for about half an hour, because I'm gonna use my music. I'm not gonna pay for an extra account for you to have music. And then, you know what? Maybe I can put on some YouTube music for you, though. That might be the thing to do. Let me try that. Anyway, if you want to participate in the stream, you're gonna have to jump over to Twitch for a while now. Bye, YouTubers. And